Good afternoon, everyone. My name is Rick Drucker, and I'm the Business Development Specialist for Lesman Instrument Company's Industrial Hygiene and Safety business. I'd like to thank you all for joining us for today's session on air sampling pumps, faults, failures, and functionality. There's an ever-increasing pressure being put on our IH customers to execute their sampling projects as quickly and efficiently as possible, all while maintaining the quality and the defendability of the results. Today's presentation will discuss the common faults, failures, and functionalities of today's air sampling pumps. Additionally, we'll discuss the methods to prevent those common faults and failures, as well as how to mitigate them prior to mobilization and what to do when they occur when sampling. We're very fortunate to have Aaron Apostolico with us today. Aaron Apostolico serves as Business Unit Manager at Sensidyne, responsible for managing the occupational health and industrial hygiene equipment product lines and providing technical support to the global marketplace. Aaron has proven experience in evaluating safety hazards, risk analysis, safety program audits, compliance review, and development and implementation of safety programs. He holds a Bachelor of Science degree in Environmental Science from Rutgers, and he also attended University of South Florida's College of Public Health for graduate studies in occupational health and safety. He holds professional designations as a certified industrial hygienist, certified safety professional, and as a certified indoor environment consultant. We welcome Aaron back as a speaker and thank him for sharing his time and his expertise with our customers. Please note that during our seminar, we're going to need to mute everyone's microphone. So please type any questions you have in the question box on the GoToWeb toolbar, and we'll be sure to cover them in the Q&A section at the end of the presentation. And with that, I'd like to welcome Aaron, thank him, and we look forward to hearing what you've got to say. Aaron, the floor is yours.
Thank you, Rick. Again, I really appreciate Lesman inviting me back. You guys have been a great partner for us, and I think this is a good topic that will interest a lot of the folks that are on the presentation with us today. So some of the things that we're going to cover today are going to be common faults, failures. We'll talk about some of the functionality of today's modern air sampling pumps. Additionally, we're going to discuss some methods to prevent those common faults, how to identify them in the field, and really how to mitigate them even prior to mobilization to make sure that your sampling event goes as smoothly as possible when you're in the field and performing the sampling. Before we get into some of the common faults, I wanted to kind of go over some of the mechanical side of what a pump is and what can go wrong or what can fail in the pump. For those of you who have never actually taken a pump apart or don't know exactly how a pump operates, I have some exploded diagram views, and I'm going to kind of discuss them briefly to help you better understand some of the components. One of the most critical components of an air sampling pump is known as the pneumatics system. So the pneumatic system is the component of the pump that actually creates the airflow. All right. Within that system, there's a motor. That motor kind of turns some eccentrics, which then have a diaphragm flex, which creates the air movement. And in order for that to really occur properly, everything has to be sealed tight in place. So that's all part of the pneumatic system. Another part of your pump system is going to be your inlet filter block. So the inlet filter block is where your hose connection goes onto your pump and then attaches to your media that's being sampled. Within that inlet filter block, there's an actual porous filter that's meant to really keep out moisture and some larger size particulates from entering into the pump system. So it is a preventative system that's part of the pump, but it can and does get clogged from time to time, and that is a component that should be checked and replaced as part of your regular maintenance schedule. We'll talk about that a little bit further. Like any engine, you have to have a battery to power it. So in this case, we have a battery component that goes onto the pump that serves as your main power source. There are some pumps that will run off of AC power that have special battery packs, and those again work in a similar fashion to provide power to the pump, but can be a source of failure as well. And then, in the main pump body, there's a main circuit board. On the main circuit board, you have two key components that again could also fail, and that's going to be your display screen and your keypads. Those do go out from time to time, and again, we'll talk a little bit more about this as we go on in the presentation, but I wanted to give a brief overview of the probably more critical components that can lead to failure, so you guys have a general idea as I discuss what the most common failures and faults are. Now, whether you're using an older manual pump, and by manual, if you're looking at the top screen here, these were pumps that were manually set for the flow rate using a screwdriver to turn a valve on the pump to set the flow rate, or you're using, or if you're using one of our modern pumps that are programmable and have push button controls. Regardless, both of them have fault systems on there. Some of the fault systems will illuminate a fault indicator light on some of the older pumps. On the newer pumps, it may alert you by a fault on the screen. It could alert you by the pump shutting down, or it could be a series of flashing lights letting you know that the pump is going into some type of fault mode. So the most common faults and failures that we see are the flow rate being out more than 5%. So what does that mean? Most pumps today have a constant flow control system on it, which keeps the flow rate within plus or minus 5% of your set flow rate as the pressure changes. So when I say the pressure changes, if you have loading on your filter media, this will increase the back pressure, but you want the pump's motor to speed up to maintain the same flow rate. Now, it knows that flow rate, and if that flow rate deviates more than 5%, that could cause a fault in your system, causing your pump to shut down. Another common fault is if the back pressure is out more than 10% in constant pressure. Now, while not all pumps have constant pressure mode, we'll talk about that a little bit more, but it needs to maintain a range within that constant pressure. If it goes outside of that range, again, your pump may shut down and go into a fault mode. A third common fault is if the back pressure range or the back pressure is out of range in constant flow. This may be a little bit different than the flow rate out or the back pressure out in constant pressure, in that if the back pressure is out of range, it could be based on a set limit for your particular pump. And again, I will give you an example of that more specifically in some upcoming slides. Next, we look at the back pressure over the high limit. So there is a threshold limit at which your pump will shut down in order to protect itself. And if that occurs, again, the pump will go into fault. And then the last subject matter that we're going to touch base on is your battery fault. And that is if the battery drains too low, will it go into fault and shut down properly or not? And there's a reason that it does shut down when it does, even though it may still have a little bit more power left. I do want to note that mostly I'll be talking about Sensidyne pumps today, but even pumps from other manufacturers have their own set points. They may be slightly different in their thresholds at which they fault out, but in general, most pumps thresholds are relatively within the same parameters. So there can be numerous causes of any one particular fault. This first one I want to kind of get into a little bit further is if the flow rate is out greater than 5%. So what may cause this? A prime example might be pinch tubing. You know, if a employee is sitting down, sometimes their body's twisted, it could cause the tubing to pinch that restricts that airflow. It might not completely block it, but if that flow rate, because of its partial blockage, deviates more than 5% from the set flow rate, it may trigger that fault in your pump. A lot of times that will cause the fault will cause it to shut down the pump. It may auto restart. In some cases, it may just alert that that fault occurred, but it may not shut down. Again, this depends on which model pump you're using. In either case, a fault indicator light will generally let you know that at some point that flow had deviated outside that acceptable range limit for that particular sampling event. Another example that I wanted to cover was back pressure out greater than 10% in constant pressure setting. So for those who are not as familiar, several of our pumps, but especially the Gill Air Plus pump, has a constant pressure high and a constant pressure low mode. In either of these modes, you can actually connect a manifold system and calibrate each one of those to have an individual flow rate independent of the pressure that is on the back end. So the back pressure created has to remain constant. And in order for it to do that, it has to see a similar pressure on the inlet side of each of the manifold pieces. However, if there's buildup on the cassettes or that tube again gets pinched, it could cause the inches of pressure to change. So you'll have it set in the picture here, we have it set at 18 inches of water. So if that were to go out more than 10%, which would be 1.8 inches of water, it would go into fault mode. I wanted to discuss a little bit more about the relationship between back pressures and faults. A good analogy for back pressure, it's like your car pulling a trailer, a boat, or a motorhome. For it to maintain that same speed, pulling the 3 different trailers, it's going to have to work that much harder. So when you have a lot of resistance and that pump has to work that much harder, it may reach a limit to which it cannot work any harder without redlining the engine. And that's why your pump will go into a fault mode. Back pressures can be affected by the flow rates as well as the filter pore size and filter loading. So those are 3 different things that have impact on the system as a whole. So when we talk about back pressure being affected by flow rates, if you had the same filter and it was clean and you were at 2 inches of back pressure at, let's say, 1 liter per minute, and you were to increase the flow rate to 5 liters per minute, the back pressure would actually increase proportional to the flow rate increasing. So it's not necessarily 5-fold, but there is a curve that actually is created as you increase the flow rate, the amount of back pressure created will also go up. So to ensure your sampling events do not experience these pump faults, it's really important to understand the capabilities and the functionality of your individual pump. The manufacturer should publish these specs, and I will talk a little bit more about several of the pumps that are on the market that have a higher back pressure capability that will fault out, but at a much higher back pressure. And that may be advantageous for your particular type of sampling. A third example that I wanted to cover is back pressure, out of range and constant flow, or over the high limit for the pump. So most modern pumps today have a stated back pressure range and limit. This is the highest back pressure that the pump can run without damaging the mechanical components in the pump. An example of this would be our Gillian 5000 pump. Can pull up to 60 inches of water at 2,000 cc's per minute. So if the back pressure were to exceed the 60 inches of water, the pump would actually fault out as a preventative measure from damaging the pump itself. As mentioned earlier, another common fault is, the battery is too low. And I often get, questions that, hey, I charged my pump, overnight, or I charged it for multiple days. I took it off, I went to use it, and it said it was full, but it only ran for 4 hours and then shut down. So a couple things could cause that to occur. One, the runtime, volume, and back pressure have internal settings to shut down when the battery gets below a certain percentage. So this occurs if there's enough power, or so this occurs so there's enough power to save the information into the memory. If you were in the middle of a run and this lower threshold is reached, the pump will fault and shut down. The fault will be recorded in the data log file if you have a data log pump. But I wanted to talk a little bit more also about battery drain. So I'll get to that in a moment. For battery drain, the more the pump motor has to work, the more drain it is on the power, or more power consumption is utilized. So the starting projected runtime may be fairly large, but if you're getting a lot of load on your filter media, in order to maintain that same flow rate, the motor is going to have to speed up. So this is like the RPMs in your car. As the motor speeds up, it's burning more fuel and causes that battery to drain a lot quicker. So that could be one of the causes of the quick battery drain for that. I'll talk about some of the other causes, but it's really important to make sure that your batteries are fully charged before you go into a sampling event. And if needed, you go ahead and make sure that your battery has the appropriate maintenance and is being replaced on a appropriate interval. Which leads me to talk about some battery maintenance issues. It's important to keep track of battery performance. Sensidyne recommends replacing your battery pack within 3 years of purchase, or approximately 300 charging cycles. Let me just discuss what a charging cycle consists of. If you charge up your pump and you run it down, you put it back on charge, it charges back up, that would be one complete charge cycle. Keeping it on charge for weeks at a time, you don't count each day. Only when you take it off of charge and you actually utilize the pump, it draws the battery down and you recharge it, would it be counted as a charging cycle. For some people, that could be a couple charging cycles a week. For some people, that's a couple charge cycles per month. Reconditioning battery packs that are left off of charge. I want to state that some people will charge their packs up fully and then take them off of charge and have them sitting in their closet or on a shelf somewhere. Most pumps are self-discharging in the sense that they'll actually discharge around 1% per day. So if you have it sitting around for 3 weeks, you've literally lost at least 20% of your battery capacity in that time period. If it goes 3 months, your battery will have almost been completely drained. So it's important to recognize that and make sure that you're getting the right power in it. Also, if your battery has sat for more than 3 months and it has fully discharged, you may have to recondition that battery to get it back into a usable format. And with the nickel metal hydride batteries, particularly, what you can do is put it on charge, let it charge up fully, then take it off of charge, let it run, put some back pressure on it if you can, so it actually runs that motor a little bit harder, depletes the energy in the pack, and then put it back on charge, let it charge up fully, and then do that again. If you can do that for 3 times, it will actually bring back that battery life as a mode to get the most performance out of that pack moving forward. So that's one way that you can recondition your battery, by charging it up, discharging it 3 cycles, and then that will actually kind of stretch that battery capacity and runtime. Lastly, reaching the end of life. So if you know that your battery is not running for a full shift under normal manufactured specified conditions, it's probably time to change out your battery. Most certainly, if it's over 3 years and it's not doing that, it definitely needs to be changed out. But a lot of times it is, subject to, how often it's used and under what conditions that it's used and charged and used again. Lastly, I will say that battery life can also be affected by temperature. I don't have that on the slide, but we do know that in colder temperatures, like in these winter months that we're seeing, the battery life is actually depleted a lot quicker under those colder conditions. That has to do with, some of the physics involved with the battery and the energy transfer. But ultimately, under colder temperatures, if these pumps are used outside, they will have reduced battery life or reduced runtime as a result of that. So another way we can go about looking at preventative measures and making sure our pumps and media, the whole sampling train, is going to be advantageous for us during our sampling event, is following, a specific, guidance for how we choose the right pump for the job. One of the things that you want to consider, first and foremost is there a method that I'm following? And this could be an OSHA method, it could be a NIOSH method. In some cases, it could be an EPA method. But the method will generally state what the sample medium is going to be, what the flow range is going to be, and then how it's analyzed. But if there's a minimum flow or minimum volume required or maximum volume required. So all of this may lead to the decision of what flow rate am I going to choose, and how will that react with the media that I'm choosing. In this particular case, I pulled up NIOSH method 7306. This is a metals panel. It's using a medium of 0.8 micron pore size. Now, a pore size less than 1 micron is going to create, much higher back pressure than a filter that would be like a 5 micron PVC. So a 5 micron pore size obviously has less resistance than something with a smaller pore size like this 0.8 micron. So think about that as you're choosing your flow rates and choosing the right pump. Again, this method gave a flow rate range of 1 to 4 liters per minute. Most common usually is right around 2.5 liters per minute. But again, that's up to each individual industrial hygienist to see what's right for their particular sampling event. The reason why I picked this particular flow rate is I wanted to correlate it to a starting back pressure. And for using a 2-piece 37 millimeter 0.8 micron pore size cassette, the starting back pressure is approximately 6 inches of water. So why is this important? Because I want to make sure that my pump has the right specifications to make sure that I don't exceed that during my sampling event. So on this slide, I show a few different types of media, and I've correlated flow rate and pressure drop with an individual media filter. So in the top graph, you can see a very common cassette used is a 37 millimeter 3-part 5 micron PVC cassette. This is used for lots of applications. There's very little resistance created by that. So you can see as it moves from 1 liter per minute all the way up to 5 liters per minute, the back pressure goes from around 1 inch of water to maybe 6 inches of water. However, if I'm using that same 37 millimeter cassette with a 0.8 micron mixed cellulose ester filter, you can see that my starting back pressure at 1 liter is going to be around 3 inches of water and goes all the way up to 15 inches of water at 5,000 cc's. Another thing to be considering is if you're using a smaller diameter filter. So if there's a less diameter, it's less surface area that actually creates more back pressure. So if you're using like an asbestos type of cowled cassette that's a 25 millimeter, expect the back pressure to be significantly higher on a 25 millimeter cassette as opposed to a 37 millimeter cassette. So I mentioned published specifications. All manufacturers should have, set parameters and thresholds published for their pumps. This is right from our Sensidyne catalog, and you can see we have 4 different Gillian pumps here: the Gillian Plus, the Gillian 5000, the Gillian 10i, and the Gillian 12. All of them have different flow rate ranges, and they also have different thresholds for fault and 8-hour runtime. And I wanted to kind of go over the differences in those specifications too, to further prepare you for what your pump, is capable of performing it. So you can see for our Gill-Air Plus at 1 liter per minute, the fault is at 40 inches. So at 41 inches, there's a good chance that it would fault out at 1 liter per minute. However, at 40 inches of water back pressure, you're draining that battery down, and it's not going to last 8 hours. Matter of fact, it's only going to last 8 hours at 35 inches. So if you know that you're having to sample for a full shift and you see that you are approaching 35 inches because of buildup on your filter, then you might need to pause the sample and or switch out your media and get a cumulative sample analyzed. So the 2 key parameters that you should look at when you're looking at your pump specifications would be at what flow rate my fault threshold is set at, which is that first column that says fault, and then that second column that has my 8-hour run is at what back pressure can it run a full shift at? What's the most back pressure it can run at? So for the Gill-Air Plus, let's look at 5 liters per minute. The highest back pressure that it can run for 8 hours would be at 12 inches of water. Now you can see as you move across that same row that for the Gillian 5000, which is one of our Power Series pumps, it has a fault at 24 inches of water at 5 liters per minute, and it can run 8 hours at up to 20 inches. So if you know that you're in a, I would say, dusty environment or have a high potential of loading that filter, you might want to choose or select a pump that has a higher back pressure capability to avoid that pump faulting out from an over back pressure fault condition. As you can see, we can move up into those, higher flow pumps. Our Gillian 10i goes up to 10 liters per minute. Our Gillian 12 goes up to 12 liters per minute. And you can see that those have bigger pumps, a little bit better motors. And because of that, it has higher back pressure fault capabilities. So if you needed to sample at, 4 or 5 liters per minute, you might want to move up to one of those higher flow pumps for the reason that it has a higher back pressure capability threshold. to avoid those faults occurring during your sampling event. I brought in this particular illustration. Our engineers test all of our pumps at varying flow rates. So what this really is looking at a correlation between runtime, back pressure, and predicted run hours. So this is how we ended up getting what is the most back pressure that pump could handle at 8 hours. And we're able to actually calculate a curve to look at each back pressure to get that information. And then of course we set a 10% margin as a buffer to make sure that, again, you're not reaching that fault within your sampling event. What this also illustrates is that, as you increase that back pressure, which is what you're seeing on your x-axis going across, you're going to significantly decrease your runtime. So now I want to just get into a little bit more about how we mitigate some of these risks. It's important to know and understand your pump specification and threshold points. It's important to know the environment that you are sampling in. As I mentioned before, if it's a high dusty environment, that's going to cause loading on your filters. If there's a lot of moisture in the air, if it's a very wet sampling environment, or you're actually sampling outside, and sometimes this occurs when it's raining. Some of the applications that are sampling are very wet applications. So this can cause loading of that filter media, which in turn can fault out your pump. Make sure you fully charge the batteries prior to use, and that you're fully confident in your battery's performance level. And if it's getting too old, make sure that you replace it so you don't have issues with battery life during your sampling event. Check your starting back pressure with the media in line. There's a couple different ways to achieve this. With our Gill-Air Plus line of pumps, we actually have a inline pressure gauge, which will show you what your starting back pressure is. So this will give you an idea of how much room you have to accumulate, concentrations of, your contaminant on your media. If you know that you're in a very high starting back pressure with that particular media, you might not want to use it in those specific environments. Periodic checks on the back pressure and battery during a sampling event. I would say back in the day when I was a consultant, we didn't have fancy electronic pumps. We actually had to go out there and fiddle with the pumps, several times during the day to make sure that, the pump was running good, that there were no faults occurring, and that, if there was a battery bar in the pump, that it wasn't drained. But in a lot of cases, it was, whether the pump was shut off when I walked up to it or not. With today's modern pumps, specifically our Gill-Air Plus pump, we have a Bluetooth app, and this is a really great way to check on your pump to mitigate some of those faults and failures maybe before they happen. So we can talk about that a little bit further. One of the other ways, if you don't have a Gill-Air Plus pump, one of our competitor pumps or one of our other product lines, is using a panel. So the picture I have here to the right shows one of our calibration panels. And on this panel, there's a magnehelic gauge. So you can actually set up your pump and your media in line and find out what your back pressure is before you even go out and start your sampling. And you may discover that, hey, my back pressure is really, really high starting at this flow rate. I'm going to either reduce my flow rate, which can bring that back pressure down, and or maybe choose to use a different pump that would give me a little, wider berth to accumulate sample loading on my filter without faulting out. So lastly, it's important, I want to plant this seed, service your pumps regularly. There's a lot of things that can also increase back pressure and those faults, and that has to do with maintenance issues that occur on your pump. As we jump ahead and we talk a little bit more about that Bluetooth and motion detection available in SDP and data logging models on the Gill Air Plus, this is a great way to monitor your pump's activities from a mobile device, but specific things that you might want to look at without having to disturb the worker would be, what's my current back pressure? And the Bluetooth app will actually tell you what it is numerically, but also graph it out. And what this can tell you is, there's loading that's either accumulating slowly on my cassette or media, or there was maybe a specific event that caused a high loading, which you can see a quick jump up in back pressure. And that may lead to a fault if you don't switch out your media early on. You can look at your total volume, you can look at your battery life, and you can actually see, what pump faults occurred, at least on our Gill Air Plus, through this mobile app. And it'll give you a fault code so you can see if I was over pressure or back pressure or battery related fault. The app also allows you to do other things like start, stop, and pause samples remotely. It records motion, which assures some sample integrity. It graphs the sample data and reviews previous sampling events in its data log. So if your pump did fault out and you have this app and it were able to turn back on, you can actually check the fault status through your app of what happened with that event that faulted out. And this app is available on both Apple and Android devices. Now I wanted to go back to why it's important to have certified factory service. I can't stress this enough. I showed you early on in the presentation that there's a lot of different parts and components and moving innards that can eventually wear out and or lead to failure. So these can include, as I mentioned, the inlet filter. It can include different seals and gaskets and O-rings. And the best way to make sure that you have a tight seal and you're getting, your consistent performance is to make sure that it is serviced on a regular basis to perform, to specification. So in our factory service center here in Florida, we use proprietary procedures, software, and tests for both commercial and unpublished specifications. We can make fine-tune adjustments, and we can also upload the latest firmware, which will again ensure the reliability and performance of your calibrator as well as your pump. Make sure that whoever you use to service your equipment, is certified and trained. It's best if they hold an accredited calibration. Our Sensidyne service center is a ISO 9001 certified facility, and we also are an ISO 17025 laboratory accredited facility. So things to note that you get with factory calibration and service is, everything is basically brought back to factory new conditions. So when a device comes in here, we'll identify what problems are, going on with it. We'll let you guys know. We'll provide an as found, and then we'll basically return it to factory new. So if that means putting in new gaskets, putting in new seals, putting in new O-rings, testing the pneumatics to make sure it's holding the right pressures and flow rates, we perform all of that testing before sending it back out to make sure that when you have that pump, you can rely on it in the field. That's really the bulk of my presentation today. Hopefully that was educational and helpful to a lot of you. I'm going to turn it back over to Rick to answer some questions. You have my contact information as well. But without further ado, I will put this back into Rick's court, and we can continue on from there.
Awesome. Thank you very much, Aaron. Got a lot of people. We've got a bunch of questions. Some of them are repeats. Will slides be made available after the webinar? This is being recorded, and we can make sure that we send out a recorded session so that you can actually see it again or listen to it again at your own time. If for any reason you don't get that, my email is right there at rickd@lesman.com. Be sure to email me and I'll make sure that you get one. Aaron, one question was, how does outside temperature and humidity impact the flow rates?
Sure. So outside temperature can affect flow rates through, the ideal gas law, which basically says, the volume of air is, proportional to the temperature and pressure. So if the temperature changes, it could cause a change in the flow rate. With some of the more modern pumps that use STP conversions, it will actually measure your ambient pressure and temperature and then adjust the flow rate to remain in line with the set calibrated flow. As it relates to the battery, colder temperatures can cause the battery to drain faster. So if you have a fully charged battery and you are nearing your thresholds, you're probably not going to get an 8-hour sample. You might want to look at, getting a pump that had higher threshold capabilities, so you can make sure that you get your, full 8-hour shift. You might also consider, well, if this is the pump that I have, maybe I bring a second pump out with me, that if it does fault because of that battery, I'm able to, calibrate another pump and have that connected to the same media, so I can now complete my sampling event for the day.
Awesome. Also, to everyone out there, if any of the questions that you've asked are, either not answered in the way that, solves your particular problem, be sure to email me that question and I can get more specific if need be. Next question, is 5% always the standard allowable flow deviation in ambient air test methods?
I would say that that's the general standard in industrial hygiene. What we typically want to see is that your starting flow rate and your ending flow rate is less than 5% apart. So if you were to calibrate your pump at, 1 liter per minute, we would want to make sure that, your ending flow rate was, within that plus or minus 5%. That really goes to the integrity of your sample, that when you start deviating more than that 5%, your ability to rely on that concentration and results starts to really deviate. So it's been a guideline more than it is I think a published, it has to be within, a certain amount. But I do know that OSHA uses that same rule as well.
Thank you. Next question. Do new pumps need to be conditioned prior to first use? For example, do you have to fully charge and drain the batteries?
So they should come to you fully conditioned. However, for shipping purposes, a lot of times they're not fully charged. So we do recommend that when you get them out of the box, that you do a full charge on it, but you should not have to recondition it.
Okay. Next one. Are there any pumps that can run 24 hours with standard back pressures?
So there are. Again, standard back pressure is, slightly loaded question, because back pressures, constantly change. So you might start out with a back pressure of 2 inches of water, but depending on where you're sampling, if it gets a lot of loading, that back pressure is going to cause that motor to speed up. Now, if it speeds up, it'll drain the battery faster. You won't get 24 hours. However, with a lot of our pumps, even the Gill-Air Plus pump, I ran a sample using a 5-micron PVC cassette at 2 liters per minute, and it ran for over 28 hours on a fully charged battery. So depending on what your flow rate is and your back pressure combined, you certainly can get over 24 hours with a single sample.
All righty. Next question. How do you know what your back pressure is as loading occurs? Does the pump display back pressure levels?
So our Gill-Air Plus pump does. It's the only pump in our line to actually display what that is. It's most certainly a benefit to have, and one of our user features. Most other pumps, and I'm not even sure if other competitor pumps display back pressure. If you don't have that, really the only way to check it during a sampling event would be to use one of those calibration panels that I showed you in the earlier slide that has the magnehelic gauge on it.
Okay.
Before you go on, Rick, there are other instruments out there that you can connect that have pressure gauges, digital pressure sensors. So any of those that are meant to measure back pressure could be placed in line with the sampling train to get that back pressure.
Okay. We have somebody that's got a Gillian 3500 pump or pumps. They've been told that Sensidyne no longer has battery packs for those pumps. What options are available? What options do they have for replacement batteries? Can the battery packs be rebuilt? Or is the unit just, what can they do with the unit at that stage?
Well, I tell you what, we've been very happy to provide in some trade-in and trade-up promotions to go with some of our obsolete equipment. We actually had that out there for quite some time, but I would be happy to extend that trade-in, trade-up, which would give some additional discount on the purchase of a Gillian 5000 or one of our other Power Series pumps.
Awesome. So to the person who had the 3500, if you want to email me with the specs, and we can talk and we can figure out if there's an appropriate pump that makes sense for you and get you a trade-in and trade-up program. Next question, how confident are you in third-party servicing of pumps in Canada now that the bridge is open?
Yes, well, assuming that the truckers will deliver it on time. Third parties are capable. I would suggest if you are using a third party, we have, certain international service centers. We do have an international service center in Canada. I would recommend that, you find our international service center through our website if that's the way you're going to go. Other third-party service centers, while they are capable of doing it, I'd be cautious that they're not using our factory parts, and then that could also void any warranties. So I would want to make sure that whoever was servicing it was affiliated with the parent company Sensidyne, or has a service center that has been accredited by Sensidyne, to make sure that it's being serviced properly and that they're using OEM factory parts in their service and repairs.
Okay. Next question. With older manual pumps, is it acceptable to adjust/document flow rates throughout a sampling cycle and calculate averages from that?
With older pumps,
is it acceptable to,
time.
With older pumps, is it acceptable to adjust and document flow rates throughout a sampling cycle and then calculate average from that?
I wouldn't say it's normally appropriate. Typically, you want to stick with a single flow rate for that particular sampling event. If I understand the question correctly, and I'll put it out there in an example, let's just say for the first hour, I wanted to sample at 1 liter per minute. And then the second hour, I wanted to sample at 1.5 liters per minute. And the third hour at 2.2 liters per minute. I would say that that's not typical. Generally, you want to stick to a single flow rate and sample that to get a total volume sampled for that concentration. There might be a specific, need or concern to do that, but I would say that that's highly irregular.
Okay. Next, why does the Gillian Connect mobile app need access to my phone's camera and access to my photos and media?
Good question. Most certainly, you don't have to give it access, but the reason that it does ask is during a sampling event, through the application, you can actually snap a picture, which will actually timestamp that picture with information of what's going on with the pump. So I'll give you a good application. Let's say I'm out sampling on a site and I see a worker that is at a station where there's, big plumes of, dust in the air. And I want to take a picture of that so I can actually say, okay, this is what was going on at the time that that pump saw that exposure. And I can actually use it. And what it will do is it will overlay a time, basically the critical information that was going on with that pump. So what the runtime was on that pump, what the back pressure was at the time the picture was taken, what the volume was at the time the picture was taken. So it'll give me the critical information, and it will actually do an overlay on the photo and then save that to your phone or device's photo log.
Interesting. Kind of related. Next question is, are Bluetooth equipped Gill Air Plus pumps new? This person would like to use the app on their phone.
So you have to have a Gill Air Plus Bluetooth model pump. If you have one of our older Gill Air Plus pumps, we do actually offer upgrades through our service center where you could send that in and we can actually upgrade it to a Bluetooth model for a fee. Again, you can contact your Rick with information if you want that done. But you must have a Bluetooth enabled pump in order to use the Bluetooth app. And no, that app and functionality has been around for, I want to say, 7 years.
Okay. Again, just to repeat, if this is something that makes sense to this particular person, please email me and we can take care of that. Next question, has Sensidyne documented the dust concentrations where back pressure causes a back pressure fault? I'm a 40 plus CIH and have never had a pump fault due to high dust levels.
Well, it really depends on the loading. So, I mean, there's not a specific concentration at which it faults. It really can depend on the type of media. I'll give you an example. I know more recently, people have been using PPI, which are particle impactors. So if you're using a size selective cyclone or impactor, there's already some back pressure created by that. If you got loading or heavy dust in those pores for the PPI, it can actually clog up that PPI and cause the pump to fault out. Other scenarios that I've seen dust collection, there were certain operations with unloading of trucks that had, a lot of dust going on even rail cars that were being unloaded with really high plumes of dust. I don't know, exactly what flow rate and concentration would be, the right scenario. But if you were trying to capture a sample that might be a shorter duration sample at a higher flow rate, that may have a higher back pressure than if you were to, let's say, sample at 2 liters per minute.
Okay. How tolerant are personal pumps in a VOC solvent environments?
One more time, repeat that.
How tolerant are personal pumps in VOC environments? And in brackets, he's got solvent.
Yep. So, the pumps are made to sample in hazardous areas and environments. Obviously, you don't want to, douse any type of solvent onto your pump itself. But in general, if it's just there and it's air sampling, it's going to get absorbed onto your, charcoal media or your silica gel media. They're made for that. Most of the pumps, especially the low flow pumps, have certain hazardous area approvals to make sure that they'll work, in those hazardous areas. If you end up pulling any type of liquid into the pump itself, of course it could, potentially damage the pump. But if you're just worried about, how it's going to act or if it's going to react with the solvent in the air, generally I would say the pumps are really safe. They've been tried and, tested true in those environments over, several decades. And we really haven't had problems with them. If you are worried, we do actually sell protective casing for the pump, which are carry pouches, which can further insulate the pump and protect pump from the environment. And if you are worried about high concentration areas, we do recommend that you get one of these carry pouches. Again, just contact Rick and he can get you set up with that.
Okay. Got one more question here.
Sure.
I'm going to do my best here because it's a long one. The plus or minus 5% deviation is specified in NIOSH and OSHA sampling and anagilic method greater than plus or minus 5% would indicate questionable sampling precision and accuracy. See Lytle and Bush or AIHA. The occupational environment, its evaluation control, first or second edition. It just seemed like a comment more than a question.
Sure. Yeah, no, I'm very familiar. And that's what I was alluding to. There's regulation and then there's, guidance documents and standards. So most certainly, all the guidance documents, state that you want to be within, 5%. Have I used as a CIH sample analysis outside of 5%? Yes, but I always put a caveat on it or an asterisk to its availability. And a lot of times I'll use it for more of a qualitative data point than I do a quantitative data point. So, that again is really up to the industrial hygienist if they want to run that sample for analysis or not. If I think that it holds merit or value, I'll run it even if it's outside the 5%, but I do put a caveat on my my conclusion that I base that on.
Okay. So that ended with the questions and comments and so forth. Aaron, we want to thank you for really giving a great informative presentation. It's really important. I mentioned again to everyone, if you have any specific application questions, if you're, have any additional questions that come up that you think of after the presentation or after you get a recording of it and something, my email is on the screen, rickd@lesman.com. They didn't put my phone number, but if I'll give you a chance if you want to write it down. It's 757-1755. In addition, if you'd like to know more about other technologies that we support, all of our webinars are posted both on our website at lesman.com, as well as our Lesman Instrument Company YouTube channel. Finally, if there are additional topics that you'd like us to cover in future webinars, please also send me an email with that subject. We have access to a lot of product and process specialists, so just please let me know what you'd like to see covered by emailing me, and we'll see if we can't get a webinar done for that. So with that, again, our main purpose is to let you know what's available, and hopefully this was a useful presentation for everyone that showed up. I look forward to seeing some emails with some questions, and we will take it from there. So there's no further questions at this point. We're going to conclude our presentation, but we want to thank everybody for attending. And again, thank you, Aaron.
It's been my pleasure. Thank you, Rick.